All right, let's dive in. We're about to uncover the fundamental choice, this sort of technological battle that quietly built our entire digital world. It's a story of two rival ideas, and, understanding which one won is the key to understanding how you're even able to stream this right now.
I mean, think about it for a second. How is it even possible? Billions of people, all online at once, video streams, emails, game data, all crisscrossing the globe, and somehow it all just works. It seems like magic, but it's not. It's actually a really brilliant engineering solution to a massive problem.
So, how do we solve it? Well, it all boils down to two totally different ways of thinking. We can frame it like this: the dedicated line versus the smart postcard. One is like having your own private reserved highway. The other is like chopping your message into 1,000 little postcards and just tossing them into the mail system. Okay, so first up, let's talk about the original champion, the idea that came straight out of the old telephone era. We're talking about circuit switching. Think of this as the ultimate reserved VIP experience for your data.
Now the key phrase here, the thing you have to remember, is dedicated physical path. Before you can even send a single bit of information, the network has to literally build a private, unbroken connection just for you from your end all the way to the other.
And this process is really methodical. It happens in three distinct phases. First, you've got to establish the circuit. This is the setup where the network connects all the dots to build your private line. Second, you actually transfer the data. That's the real conversation. And finally, when you're all done, you disconnect the circuit, and all those resources are freed up for someone else.
This is exactly how old-school landline phone calls worked. When you dialed a number, a series of switches physically connected a copper circuit from your phone all the way to the other person's. And for that entire call, that line was 100% yours. No one else could use it.
And right there, that's the big problem. This model is perfect for a non-stop phone call, but it is wildly inefficient for how computers talk. See, computers send data in short, sharp bursts, with long, awkward silences in between. With circuit switching, you're paying for that dedicated line even when absolutely nothing is being sent. It's like renting an entire 4-lane highway just to drive on it for 5 seconds every minute. A total waste.
So that massive inefficiency created the need for a completely new way of thinking, something designed for the stop-and-go nature of computer data. And this brings us to our other contender, the smart postcard method, which is officially called packet switching.
So instead of one huge message on a private line, packet switching takes your data, your email, a photo, whatever it is, and it chops it up into lots of tiny pieces. We call these packets. And here's the crucial part. Each and every one of those packets gets its own little address label, just like a postcard you'd drop in the mail.
And the magic that makes this whole thing work, the real secret sauce of the internet, is a concept called statistical multiplexing. Now that's a fancy term, but the idea is actually super simple. The network's bandwidth is a shared public park, not a bunch of private yards. Resources are used only when someone actually has a packet to send. Now, these little packets can travel in a couple of different ways. Sometimes, like you see on the left, each packet is on its own adventure, finding the best path it can. They might even show up out of order. Other times, they follow a pre-planned route, kind of like a convoy of trucks. But the big takeaway here is flexibility. The network adapts, and that's pretty much how the internet works today.
Okay, so we've got the dedicated line versus the smart postcard, the private highway versus the public mail system. Let's put them side by side and see how they really, truly stack up against each other.
When you look at them head-to-head like this, the differences just pop. Circuit switching's dedicated path is awesome for voice, sure, but when it's full, you just get a busy signal. It's an all-or-nothing game. Packet switching, though, it shares everything, which is way more efficient. But what happens when it gets overloaded? It doesn't block you. It just slows down. Your data gets stuck in a digital traffic jam, which you've probably heard of. We call it congestion.
And you can see that performance trade-off perfectly right here. On the left, with circuit switching, notice that gap at the beginning? That's the call setup delay, all that time wasted building the private path before a single thing can be sent. Now look at packet switching on the right. The data starts flowing immediately, no waiting around. So in this huge battle to build the backbone of our digital lives, there was a very, very clear winner. Let's break down exactly why one idea completely crushed the other.
The winning formula was just simple and unbelievably powerful. Packet switching is wildly more efficient, it's cheaper because it shares everything, it's incredibly scalable, adding another billion users is no big deal when they're all sharing the same roads, and maybe most importantly, it's resilient.
If one connection in the network breaks, the packets just find another way around the problem. The internet heals itself.
And this is why it all matters to you. Right now, that core concept of shared resources, of statistical multiplexing, is the entire reason your whole house can be online at the same time. Everybody's smart postcards, from your movie stream to a video call to a game, are all zipping through the exact same shared system, making it all possible.
You know, packet switching was the revolutionary idea that made the internet we know and love possible. But it was designed for the problems of its time. As we head into a future of instant, real-time gaming, massive virtual worlds, and an Internet of Things connecting every device in our lives, you gotta ask, is the smart postcard model still the right one for the job? Or is a new battle already heating up to define the network of tomorrow?